Today we're talking about structure, and specifically structural collapse, what it looks like, why it matters, how it sneaks into your pipelines, and practical ways to recover and prevent it. This will be a clear example-first walkthrough, friendly and practical. So whether you're just learning data engineering or you shepherd production models, you'll walk away with usable actions. Let's start with an intuition. Structure is the set of guarantees your data gives you: field names, types, keys, relationships, and validation rules. Collapse is what happens when those guarantees fail catastrophically. It's not just a minor inconsistency, it's a breakdown where data stops behaving like data you can reason about. Imagine relying on a table that suddenly loses its primary keys, or a dataset where numeric fields become free text. That's structural collapse. Here's a concrete story. You have an orders table used across billing, analytics, and reporting. Every order used to have order ID, customer ID, amount sent, and created at. Over time, a vendor integration pushed in records without order ID for a subset of rows. Another team started storing amount as a string like 1000. Later, a time zone conversion rewrote created at with inconsistent formats. Analytics jobs started failing, reconciliations were wrong, and downstream alerts went silent. That cascade, culminating in outages and bad decisions, is structural collapse. Why does collapse happen? A few patterns appear again and again. First, ungoverned schema changes. Someone changes a source without notifying consumers. Second, flexible storage choices. Schemaless systems let data drift without constraints. Third, silent migrations or faulty backfills that overwrite keys or remove constraints. Fourth, extreme heterogeneity from third-party data or scraping where validation was never enforced. Finally, operational mistakes, jobs crashing mid-migration or partial writes leaving half-baked records. What's the real damage? Structural collapse causes silent data corruption, unreliable analytics, broken joins, and models trained on poisoned data. It increases mean time to detect and repair. Instead of a small ETL tweak, you face cross-team incident response, manual reconciliation, and lost trust in your data. And unlike an obvious crash, collapse often produces subtly wrong outputs, the worst kind because it's believable. So how do you detect collapse early? Begin with guardrails rather than hope. Monitor schema health. Track presence of key fields, type distributions, and uniqueness for identifiers. Watch for sudden spikes in nulls, unusual type mixes, numbers turning into strings, or shifts in cardinality. Set anomaly alerts on downstream metrics that should be stable. Sudden drops in join rates or reconciliation mismatches often point back to structural problems. Steady. Sample data regularly and include human review of edge cases. Automated signals plus periodic eyes-on checks catch more than either approach alone. When collapse has already happened, follow a repair pattern. Triage, repair, restore trust. Triage by scoping the damage, which tables and time ranges are affected, which consumers broke, and which records are corrupted. Repair by constructing canonical reconciled versions, for example, rederiving keys, normalizing formats, and rejecting or isolating ambiguous records. Sometimes you'll need to roll back to a known good snapshot or replay ingestion with corrected transforms. Restore trust by publishing the scope of impact, the fixes you applied, and adding tests so the same failure won't creep back in. Now for prevention, the investments that make collapse rare and survivable. Start with schema contracts. Require producers to declare a minimal contract for entities, key fields, types, and invariants, and validate at source. Use contract tests and CI checks so changes fail fast before they reach production. Apply constraints where practical, unique keys, non-null constraints, and type checks in the storage layer if available. For schemaless stores, implement a strict validation step at ingestion that either normalizes or quarantines bad records. Automation and observability are critical. Make schema drift alerts part of your pipeline. Surface lineage, so you can quickly trace which upstream change caused a downstream failure. Version your schemas and migrations, so changes are auditable and reversible. Provide shared libraries or service APIs that produce canonical records. When teams reuse the same serializers and validators, drift is much harder. There's also an organizational angle. Collapse often reflects unclear ownership. Designate domain owners for critical entities and encourage a data as product mindset. Producers are responsible for the quality of what they publish, and consumers treat data as a product with SLAs and tests. Make schema change processes lightweight but mandatory. No surprise, breaking changes. Finally, adopt a resilient mindset. Design pipelines to fail safely. Instead of silently accepting malformed records, isolate them, surface alerts, and let systems degrade gracefully. Create runbooks for common collapse scenarios. Teams that know how to act recover faster and with less collateral damage. To wrap up, structural collapse is a severe but manageable risk. It starts with small violations of assumptions and grows when there are no guardrails. Detect it with schema and lineage monitoring, fix it by scoped repair and replay, and prevent it through contracts, automation, and clear ownership. If you take one thing away today, bake validation at the edge. Validate on ingest, not after the damage is done. See you in the next one.